Hello everyone and welcome to Intro to Trigonometry. Please make sure you have your packet in front of you. This is starting on page 3. The first thing it says is in right triangle DEF, the length of side DE, find the length of side DE. DF is equal to 5 and EF is equal to 3. So to find the length of DE, DE would be x in this case. There's two ways to do it. You can either use the Pythagorean theorem or just remember your 3, 4, 5 triplets, which I've mentioned on several occasions. So this has to be 4. The next part, it's asking for the hypotenuse. The hypotenuse is the side of the triangle that is across from the right angle. That's always the hypotenuse. We've seen that before in the Pythagorean theorem using a squared plus b squared equals c squared, and c is always the hypotenuse. The next one, it says adjacent. It's the leg of the triangle next to the angle, and it's not the hypotenuse. It's very important that you realize that adjacent sides could be different depending on which angle you're standing next to. And then the last one, it says opposite. That is the leg of the triangle that is across from the angle, not the hypotenuse. So, if we were to take a look at the next part, I need to move the definitions out of the way so you can see it. So hopefully you've copied those. I'll give you a second or two to copy them. Okay, now it says starting from D. So if I was starting from D, that's as though I was standing at D in the triangle. The hypotenuse is definitely 5. The adjacent side, technically there are two adjacent sides, the 4 and the 5, but the 4 is the important one because it's not the hypotenuse. And then the opposite side from D would be all the way across at 3. So it's very important that you realize that we're talking about sides that are adjacent or opposite, but based on what angle we're standing next to. So the next part of the question says starting from F. So if I was starting from F now, first of all, the hypotenuse is still 5, which is nice. The adjacent is actually my 3, and the opposite in this case is my 4. Notice that these are different than starting at D. So starting at D and starting at F, they're going to give you different opposite and adjacents. The one that would be the same is still the hypotenuse. Let's take a look. Moving on. The sine, or SIN. The sine is technically the ratio of the opposite side to the hypotenuse. So it's the opposite over the hypotenuse. The cosine is the ratio of the adjacent to the hypotenuse. And the tangent is the ratio of the opposite to the adjacent. So in this case, there's a little thing that everybody remembers. It's what we call Sohcahtoa. And Sohcahtoa reminds us that in sine, it's opposite over hypotenuse. In cosine, it's adjacent over hypotenuse. And in tangent, it's opposite over adjacent. So whenever you can, you should probably write out Sohcahtoa. Make sure it's Sohcahtoa. Okay, so now it says, use the triangle above. I just redrew it here on the right. Use the triangle above, find sine of D. So I'm going to pretend that I'm standing at D. Sine is supposed to be opposite over hypotenuse. So the side opposite would be the 3 over the hypotenuse, which would be 5. The next one, it says cosine of D. So I'm standing at D. Cosine is adjacent over hypotenuse, so it would be the 4 over the hypotenuse, which is the 5. And then the last one, which is the tangent of D. Tangent, if I'm standing here at D, is opposite, which is the 3, over the adjacent, which is the 4. So it would be 3 over 4. Now, when I go to stand at a different angle, for example, at angle F, for the next column, I'm going to do it in red, my sine is going to be my opposite over my hypotenuse. My cosine is going to be my adjacent over my hypotenuse. And my tangent is going to be my opposite over my adjacent. So 4 over 3. Okay, copy those, please, so we can go to the next page. Now, working on the next page, we are going to write Sohcahtoa in the top box. Sohcahtoa. And then if we're doing sine of u, we know I'm standing at u. Sine is opposite over hypotenuse. It would be 8 over 17. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. So I'm not going to use the 8 and the 17. Instead, I'm going to use the 15 and the 17. And then tangent is opposite over adjacent. So in this case, the opposite is 8 and the adjacent is 15. So it winds up to be 8 over 15. Now I'm going to repeat the same thing for standing at angle P. So if I'm at angle P, the opposite is 15 over 17. The cosine is 8 over 17. And the tangent is opposite over adjacent is 15 over 8. You can notice a pattern that starts to develop. Now we're going to look at the next triangle. Now in the next triangle, it asks us to find the 3 trig functions. So I'm going to start at C, and sine is opposite over hypotenuse. Opposite is 5 over the hypotenuse. Oh no, I don't have the hypotenuse. So no need to worry. We could either do the Pythagorean theorem, or we could realize that this is a 5, 12, 13 triplet. You're welcome for making you memorize them. So the sine is the opposite, which is 5 over 13 for angle C. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. And then for the last 3 ratios here, I'll do them in red. And assuming that we are not using, we're going to start here at B. Opposite over hypotenuse, 12 over 13. Adjacent over hypotenuse, 5 over 13. And tangent opposite over adjacent is 12 over 5. Now, that's pages 3 and 4. I'd like you to try page 5 on your own. So I need you to do numbers 3 and 4 on page 5. Thanks, and I'll see you tomorrow.